Students, it is the first lecture of this week. Here I present an example number 1 of factor analysis. The detail of factor analysis has been explained in last 2 lectures of previous week. So listen it. Obtain a one factor solution for capital lambda and psi for the model x is equal to capital lambda f plus e using the correlation matrix, showing that the correlation matrix is between children examination performance in class 6 x1, French x2 and English x3. Here correlation matrix has been given here. As you know well that the diagonal element of a correlation matrix is always unity, and all diagonal elements are less than or equal to 1. Here p is equal to 1. The solution is given here. Here p is equal to 1. That is the number of variables. Number of variables are classics, French and English. And m is equal to 1. That is factor. Factor is a examination performance. So s is equal to 1 over 2 into p minus 1 whole square minus 1 by 2 into p plus 1, which is equal to 0. When s is equal to 0, then there exists a unique solution. So there exists a solution for model x is equal to capital lambda f plus e. We have let me increase the size of this text. That is, I think now it is readable easily. Now m is equal to 1 and p is equal to 3. Therefore lambda is equal to lambda 1 1 head, lambda 2 1 head, lambda 3 1 head, and psi head is equal to psi 1 head 0 0, psi 2 head 0, and psi 3 head. All diagonal elements of this matrix of psi head is always equal to 0. Rho is equal to capital lambda into lambda plus psi. Capital lambda is given here. Sorry, lambda is given here. Lambda 1 1 head, lambda 2 1 head, lambda 3 1 head. Similarly, take the transpose of this column matrix, which is a row matrix, plus the value of psi head. So phi is equal to, phi has become lambda 1 1 square plus psi 1 head plus lambda 1 1 head plus lambda 2 1 head, lambda 1 1 head into lambda 3 1 head. Similarly, lambda 2 1 square plus lambda psi 2 head plus lambda 2 1 head into lambda 3. It will be, I think it will be 3 1 head and lambda 3 1 head into lambda 3 head. The respective values of these expressions, that is lambda 1 1 head plus psi 1 head is equal to 1, and lambda 1 1 head and lambda 2 1 head is equal to 0.83. Similarly, lambda 1 1 head, lambda 3 1 head is equal to 0.8. So you can compare these. Values and rewrite these equations. These are 3 equations. These are 6 equations which we have obtained by matching above correlation matrix with this equation, with this matrix, by matching above 2 matrices. Now lambda 1 1 head square is equal, lambda 1 1 head square plus lambda 1 psi 1 head is equal to 1. Lambda 2 1 head square plus psi 2 head is equal to 1. Lambda 3 1 head square plus psi 3 head is equal to 1. Similarly, lambda 1 1 head, lambda 2 1 head 0.83, lambda 1 1 head, lambda 3 1 head 0.78, lambda 2 1 head, lambda 3 1 head is equal to 0.67. After solving these equations, Here's the solutions of these equations. From equation number 4 we can obtain this equation, and from equation number 5 we obtain this equation, and after simplifying these equations we obtain the values. You can see the process of solving these equations. We have obtained the values of lambda hat and psi are given here. Lambda 1 hat, lambda 2 1 hat is equal to 0.844, and lambda 3 1 hat is equal to 0.793, and lambda 1 1 hat is equal to 0.983. Similarly, psi 1 hat is equal to 0.034, and psi 3 hat is equal to 0.371. Simply we have solved above 6 equations simultaneously and obtained these values. Therefore, and lambda 3 psi 3 hat is equal to 0.370. Now x is equal to capital lambda f plus e. X is equal to x1, x2, x3, which are the three variables, and lambda 1 hat, lambda 2 1 hat, lambda 3 1 hat, f1 plus e1, e2, e3. Now replacing the values of here, values of lambda 1, lambda 2, lambda 3. x1 is equal to 0.983 f1 e1 plus lambda, and x2 is equal to 0.844 f1 plus e1, and x3 is equal to 0.793 f1 plus e3. Now I will share here another example. It is not an example, I think only a text about previous example. Unfortunately, listen attentively. Factor rotation. Unfortunately for the factor analysis, most covariance matrices cannot be factorized as lambda as sigma is equal to sigma, that is variance covariance matrix, is equal to capital lambda into capital lambda hat plus psi, where the number of factors m is much less than p. The following example demonstrates one of the problems that can be arise when attempting to determine the parameters lambda ij and psi I from the variances and covariances of the observable variable. Let p is equal to 1, m is equal to 1, and suppose that the random variables are x1, x2, x3. We have the definite matrix, that is variance covariance matrix. Sigma is equal to 1.0, 0.9, 0.7, 1, 0.4 and 1. Using the factor model, sigma is equal to capital lambda f plus e, where sigma is equal to capital lambda into capital lambda hat plus psi, where capital lambda is equal to is a column vector, lambda 1 1 hat, lambda 2 1 hat, lambda 3 hat, 3 1 hat, and psi hat is equal to psi 1 hat 0 0, psi 2 hat 0, and psi 3 hat. Sigma may be right in this form. After solving, we have obtained that one, variance covariance matrix. Now what's the problem? Comparing it, sigma is equal to 1.0, 0.9, 0.7, 1, 0 and 1. Let me minimize this text so that it may become readable. Now from above equations, from comparing above two matrices, lambda 1 head square is plus lambda psi 1 head is equal to 1, lambda 2 1 head square plus psi 2 head is equal to 1, lambda 3 1 head plus psi 3 head is equal to 1, lambda 1 1 head, lambda 2 1 head 0.9, lambda 1 1 head, lambda 3 1 head is equal to 0.7, lambda 2 1 head, lambda 3 1 head is equal to 0.4. Dividing equation number 5 by 6, we got lambda 2 1 is equal to 0.61 lambda 1. Putting the value of this lambda 2 1 equation number 4, we get lambda 1 1 is equal to 1.221. From equation number 1, we have psi 1 is equal to minus 0.5. Here is the problem, because psi is a variance which is unsatisfactory, since it gives a negative value of variance, error term, that is residuals E1, the variance of residual terms, that is error term. Therefore variance of E1 is equal to minus 0.5, but the variance cannot become negative. Thus, for example, with m is equal to 1, it is not possible to get a unique solution. Moreover, the solution is not consistent with the statistical interpretation of the coefficient, so it is not a proper solution.